Bam. When a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table, a rate modeled by. So remove, this is a rate, and it's remove. So we're not talking about how many are on the table. It's talking about the rate at which they remove. Where F of t is measured in pounds per hour, and t is the number of hours after the store opened. After the store has been open for 3 hours, store employees add bananas to the display table at a rate modeled by. So what stuck out, what after 3 hours? What stuck out for me? Yeah, that's right. That's a word, isn't it? Yeah. Is that after 3 hours, they started place adding. Where G of t is measured in pounds per hour and t is number of hours after the store opened. A, how many pounds of bananas are removed from the display table during the first 2 hours the store is open? So we're going to integrate from 0 to 2 of, what do they want, remove, how many pounds are removed, of F of t dt. So that's math number 9 on a calculator and 20.051. So 20.051 pounds. B, find f prime of 7, use correct units, explain the meaning of f prime of 7 in the context of the problem. So f prime of 7 is equal to, and we don't do this very often during the year because I want you to take the derivative of functions and get a lot of practice for that, but now that we're towards the end, if we can use a calculator, let's use the calculator. Math number 8 does derivative at a certain value. So we're taking the derivative with respect to x. We have, which one? I'm doing f. 10 plus 0.8t sine of t to the third divided by 100. And we're evaluating that at 7. So we get negative 8.119, negative 8.119. Now we're going to interpret it. The rate after 7 hours let's see, the rate after 7 hours that the rate is changing. No. Here. I'm all messed up on that one. After the store has been open 7 hours, the rate at which the bananas are being removed, the rate of the rate from the display table is decreasing by 8.119 is the number that I used. Pounds per hour per hour. Or I usually put pounds per hour squared. I really nailed that one all day. Then I kind of messed that one up. I was not off to a good start. But you kind of have to mention that the rate that they're being removed. So it's the rate of the rate. That's why the label looks like acceleration. But it's decreasing because it's negative 8.119. All right. C, is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Well, the rate that it's increasing or decreasing is, let's see, add would be g of t, and then minus f of t is the rate at which the table is changing. All we have to do is evaluate g of 5 minus f of 5. And we just have to plug in values for that. You could use your calculator, plug in values. Let's cheat. It ends up being negative 2.263. Negative 2.263, which is less than 0. That's really given a reason why it ends up decreasing. How many pounds of bananas are on the display table at time t equals 8? Now this one's a little tricky. First of all, we got to use the initial value. All the way back up here, it says initially we have 50 pounds, 50 plus, and then we're going to add, but we're going to add after 3 hours. So I think this piece would be tricky in that you have to go 3 to 8 instead of 0 to 8, because you don't start adding right away. So g of t dt, and then plus, we remove, so that's minus. Oh, geez, here we go. dt minus integral. Now this is 0 to 8, because it said they remove right away, of f of t dt. So you got to do a couple math number 9s to do integral, and it ends up being 23.347. 23.347. How many pounds of bananas are on the table? Pounds. At this time, I assume that you know how to do I assume you know how to do integral on your calculator, and you do. All right, next one. Fish enter a lake at a rate modeled by the function e, given by e is that function. Fish leave the lake at a rate modeled by function L. Both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight. So E for enter, love it. L for leave, love it. How many fish enter the lake over the 5-hour period from midnight to 5 a.m.? Give your answer to the nearest whole number. How many? And these are both rates. So again, we're going to integrate from 0 to 5 of E of t dt. So that one hopefully is pretty straightforward for you. Going from rate to how many? Back up, integral. 153.457. That is how many? So fish. Oh, and round to the nearest whole number. So 153 fish. What is the average number of fish that leave the lake per hour over the 5-hour period from midnight to 5? So average number of fish that leave. And we have a formula for leaving. And it says per hour. So that means, what is the average rate? Well, we have a formula for the rate. So it's not like, we're not doing slope. We're doing the integral piece, where it's 1 over 5 minus 0, integral from 0 to 5 of L of t dt. Let's cheat. 6.059. 6.059, and that's the average number of fish that leave the lake per hour. So fish per hour on average. At what time t for 0 to 8 is the greatest number of fish in the lake? So on letter C, the greatest number. So we're going to maximize the amount is really what they're saying. So that's like position function. So how do we maximize a position function? We take the derivative. That'll be the rate. We want enter. We want E of t minus L of t to equal 0. That's what we're looking. There's going to be our critical values. So I thought, well, I'll show you how to do this on the calculator. Y equals. In Y1, I'll put the enter. So 20 plus 15 sine of pi x divided by 6. And then 4 plus 2 raised to the 0.1 x squared. The window I used is 0 to 10 for the x's, and then 0 to 100 for the y's. So we graph it. Here's the sine function. And then the exponential, hopefully you expect it to just go off to infinity eventually. Whoops, I typed that in wrong. I got 0.0. 0.1. There we go. 0.1. There's the sine. Now we'll see that exponential function head off to infinity. There we go. There it goes. We want that intersection point right there. So second, calculate intersection. Go over to it. Bam. Second curve. Guess. So t equals 6.203 hours. And how do I know that? How do I know that that's the maximum? Well, E of t minus L of t changes from positive to, let's go positive to negative. Because if you have E of t is bigger minus L of t is smaller, that's going to give you a positive rate. And then up here, we're going to have a negative rate because they switch places. So we change from positive to negative there. Is the rate of change in the number of fish in the lake increasing or decreasing? So in other words, what's the rate of the rate at 5 a.m.? So this one is E prime of t minus L, actually L prime of 5. We have an actual value. E prime of 5 minus L prime of 5. And again, you know, earlier we didn't use our calculator a lot for derivative because we want you taking derivatives of functions. We want you practicing that and getting better. But if we can use our calculator, we're going to use math number 8. With respect to x, now I already have those equations in y1 and y2. So let's go y1 at 5, and then minus math number 8 with respect to x. And I have this one in y2. Function y2. Go over to 5, and we get the value, negative 10-ish. Negative 10.722. And what is the rate of what is the rate of change increase? Oh, that is less than 0, so decreasing. How about looking at what you might see on multiple choice? So the first thing you should do on limits is just plug the values in and just see if it works. So e to the 0 minus cosine of 0 minus 2 times 0 over 0 minus 0. And it's a good chance it won't work on the AP test. So 0 over 0. That's an indeterminate form, and they're looking at L'Hopital's. But they could give you one that just works. I doubt it, though. So we have L'Hopital's. Limit as x approaches 0 of e to the x plus sine of x minus 2 over 2x minus 2. And now we plug 0 in. E to the 0 plus sine of 0 is 0 over 0 minus 2. So 1 minus 2 is negative 1 over negative 2. So we're looking at 1/2 for an answer. So quick review of L'Hopital's. For 0 to 13, an object travels along an elliptical path given by the parametric equation. At the point where t equals 13, the object leaves the path and travels along a line tangent to the path at that point. What is the slope of the line on which the object travels? So we need the slope of the tangent line. That's derivative. That's dy over dx. So the derivative of y is 4 cosine. And the derivative of x is negative 3 sine. Now we're going to evaluate that when t is 13. So 4 cosine of 13 over negative 3 sine of 13. Now we don't see any decimals as one of the answers, so we're not worried about that. But it's in terms of in terms of tangent. And we can write this as negative 4/3 cotangent of 13. But all the answer, now we're kind of answer hunting. And we've done most of the work. Now we have to see how did they manipulate it to get the final answer. Well, cotangent and tangent are reciprocals of each other. So we can write that right there, which ends up being letter D, I believe. Yeah, letter D. So if you ask me, hey, do we need to rationalize denominators? Not on free response, but you might have to go answer hunting on multiple choice. What are all values of p for which that converges? That's an improper integral, and so we need 2p to be greater than 1. That'll keep all the variables in the denominator. And so when we plug infinity in, we're going to 0. So p has to be greater than 1/2. Another partial fraction one, we need that original integral to look like a over x plus 2 plus b over x plus 1. And you can see that all the answers have natural log in them because now we have the denominators as a power of 1. So 2x has to equal a times x plus 1 plus b times x plus 2. So we're going to let x equal -1. So -2 is equal to b. Let x equal -2. So -4 equals -a. So a is equal to, I'm getting 4, which kind of matches those multiple choice numbers. I see 4s and 2s up there. That's always a nice check to kind of see if you're on the right track. So now we're integrating 4 over x plus 2 minus 2 over x plus 1. Four natural log absolute value of x plus 2 minus 2 natural log absolute value of x plus 1 plus c. And that's actually how they have the answer. We're looking at D. So they don't actually do the division of the natural logs. And finally, I threw up this chart here. Let's see, the table above gives values of f, f prime, g, and g prime at selected values of x. If h of x equals this, we're going to find h prime. So let's find h prime. And this is pure chain rule. Derivative of the outside times derivative of the inside. So derivative of the outside, leave the inside alone, and then times the derivative of the inside. That's how we do chain rule. Now we plug the values in. So h prime of 1 is f prime of, let's see, g of 1 is -1. And g prime of 1 is 2. But then f prime of -1 is 5. So 5 times 2, we're looking at 10 for an answer on that one.